Okay, welcome to Gravity Week and the presentation that went along with that. We studied gravity last week through the eyes of three scientists. The first being Galileo, Sir Isaac Newton, and then Albert Einstein. I'll start with Galileo, who lived from 1564 to 1642. Now, Galileo did not study gravity per se, but he worked with an important part of gravity that led to other discoveries. He studied falling bodies, so how objects fell with a series of experiments. And through his experimentation, he discovered that bodies or objects that start with the same velocity will fall at the same rate, regardless of how heavy or light they are. And he dovetailed this on to say that without air resistance, all bodies will fall at the same rate. He came up with this idea in kind of a mind experiment and tested it by dropping equal-sized cannonballs of different masses off the Leaning Tower of Pisa. He had one that was solid and one that was hollow. They were both the same size around. And what he discovered when he dropped these after repeated trials is that they always landed at nearly the same time. And he took this as proof of his thinking process that objects without air resistance would fall at the same rate. Now, we can go someplace since Galileo's time and test this, and one of the places we can test this is on the surface of the moon. And so through experiments like this one that took place on the surface of the moon. Now, the moon's a good place to test this because there is no atmosphere, so no air resistance. He dropped a hammer and a feather, and it appeared in the video that they both landed at the same time. Now, we can also test this on Earth in special areas called gravity chambers. So I'm going to take you through an elaborate gravity chamber experiment where they tested a bowling ball against a series of feathers. Okay, so we're going to skip ahead to one of the actual tests. Now this still has air in the chamber. So as you would expect, the feathers fall at a much slower rate than the bowling ball. So we're going to have to fast forward ahead until they pump all the air out. Close the door and pump the rest of the air out of the chamber. So they got the air pumped out, and they'll count it down. Now they're going to drop this and slow it with a slow motion camera. And if you watch side by side, the bowling ball and the feather are following at exactly the same rate. Now the feathers were a little longer than the bowling ball to begin with, but if you notice, they fall right side by side with each other. Just as Galileo predicted and then tested through experimentation. Notice the feathers even bounced in zero gravity. So to summarize Galileo's findings, he discovered that all objects fall at the same rate. Next guy on our list is Sir Isaac Newton, and Sir Isaac Newton was born the exact year that Galileo died. He took Galileo's concepts about falling objects and applied and said, that force that's causing those objects to fall the same rate is a force called gravity, and that's a universal force, and it's caused by mass. And he said every mass attracts every other mass in the universe. He said gravitational forces between two bodies is the product of their masses and inversely proportional to the square of the distance between them. Now that's complicated, so let me say it a little bit simpler for you. Sir Isaac Newton said more mass means more gravity. Every object that has mass has gravity. The more mass you have, the more gravity you have. He says the farther apart things are, the more distance there is, the less gravity is going to have an impact. Finally, he said gravity is a universal force, and that orbits are the result of gravity and forward inertia of the objects moving through space. I'm going to skip ahead through this little video. And so again, Sir Isaac Newton found that gravity is universal, that more mass is more gravity, more distance is less gravity. All objects are attracted by the forces of gravity. I have gravity, you have gravity. The reason we're not attracting each other, at least gravitationally, is because our mass is very small, insignificant on a universal scale. Final scientist in our study is Albert Einstein. Albert Einstein lived much later. He was born in 1879 and passed in 1955. He is credited with the general theory of relativity. He took Newton's theory of gravity and kind of turned it on its head a little bit. He said gravity is a distortion of space-time. Let me explain what that means. Einstein saw the universe as being four-dimensional. One-dimensional is like a line, it's only got length. Two-dimensional universe would just have length and width, like a rectangle. A three-dimensional universe, which is similar to what we have, would have length, width, and height. We use the term 3D. The fourth dimension is time, so you go length, width, height, plus time. You get the universe, which Einstein referred to as space-time. He said that very massive objects create these gravity wells, these dimples in space, where an object doesn't really pull another object towards itself, it actually pulls all of space-time towards itself. And so these dimples in space are called gravity wells. And an object that is caught in a massive object's gravity well will cycle down the well, kind of like a funnel, toward that object. Objects that orbit are caught in the gravity well, but have enough forward inertia to maintain their distance. And so Einstein's thesis was masses will warp space-time.